So hello and very good morning dear students. I hope you all are well and are ready for the math class. So today we are going to start the new chapter, that is the very first chapter of your book, Rational and Irrational Number. Okay, so before starting rational and irrational number, we need to understand certain type of numbers which are required to be known to you. Okay, so I'm starting with the natural number over here. In the lower classes, I hope you have seen all these types of numbers, but let's have some recap of all these numbers. So first, starting with the natural number. You know what are natural number? The numbers which are starting from 1, 2, 3 and so on up to infinity. So they are called natural number. Whole number, including the natural number, if you add one more digit, that is 0, then the set of all those numbers are called the whole number. Then even number, the numbers which are divisible by 2, they are called even number, like 2, 4, 6, 8, 10 and so on up to infinity. Odd numbers, the numbers which are not divisible by 2, they become the odd number. Integers, now what is the meaning of integers? In integer there is the positive natural number, negative natural number and 0 also. So set of all these numbers are called integers, and we know like integers are of two types, that is positive integer and negative integers. Okay, and we can understand that if in the number system, if we go the left side, it is the negative integers, and if we go in the right side, then that is the positive integer. Then prime number also, we know the numbers which are divisible by itself and 1, that is prime numbers. So you need to write the definition of all these numbers. Okay, that will be the homework for you. Now coming to the main topic, that is rational number, which we are going to see in this chapter. So let's define what is called the rational numbers. Okay, so rational numbers, first of all let me define the numbers which are represented in the form p by q, where p and q are integers, and the very most important condition, q should not be equal to 0. Did you get this? That the numbers which can be represented in p by q form, where p and q are integers and q is not equal to 0. So this is the definition of rational numbers. Okay, p by q form means, say for example I'm saying 11 by 5 or 31 by 37. So they are in the form of fractions, right? P upon q form, and p and q are integers. Here 11 and 5 are integer here, and q should not be equal to 0. Why I said that this condition is very important for us, q should not be equal to 0? It says denominator should not be equal to 0, because if you divide anything with 0, you will get a not defined. That means it is not defined in mathematics. You cannot divide anything with 0. Okay, that is why 1 upon 0 is not defined. Okay, and as I have already made a video on this mathematical fact, why 1 upon 0 is not defined, you can go and watch that. Okay, so coming to the topic here, rational numbers, as I told you, they are in the form p by q, where p and q are integers and q not equal to 0. Now we are going to see that how many type of rational numbers are there, because mainly there are two types of natural number. Okay, so let me just write here. So the rational number are of two types. One is terminating and another one is non-terminating. Okay, let me write this properly and give you the example. Let me rub it. So rational number, they can be understood in two ways. See, actually how we can express a decimal, that they are trying to say that how can you express decimal in two ways. So that is what I am also saying, that actually decimal comes from a fraction, and fraction can be called as rational numbers. Okay, so that is what we are going to do. That is how the decimal can be expressed in two ways, or rational numbers directly we can say they can be expressed in terminating decimals and non-terminating or recurring decimal. Now what is the meaning of these two? Let's understand. So you might have seen somewhere, or might you have come across two types of divisions or fractions, we can say. Sometimes what if I divide 5 by 2, I get 2.5, but sometimes if I'm told to find 1 upon 3, I get 0.333333 and so on up to infinity. So that is how they have categorized such type of two division in two ways, that if it is 5 by 2 and if your answer is 2.5, then over. That means this digit has terminated itself to 5. So that is why they are called the terminating decimals. Now what happens if your answer, or like if the same digit is repeating and it is going up to infinity, so it could not terminate itself. So that is why we say it is a non-terminating or recurring decimal. Okay, so the two names are there. You need to remember these two names. Okay, I have written these two examples, 3 by 4, which is what, 0.75, and here 1 upon 6 is 0.1666666, and this 6 is going up to infinity. That is why it is called non-terminating. Now in the non-terminating, you need to understand one more thing. Just to express this, how do we write 0.3 and 1 point on the number or the digit which is repeating? Okay, so here also what will be the answer? 0.16 recurring. And how do we call this? Is 0.3 recurring, 0.16 recurring, which means this 6 is repeating. Now sometimes what happen, you may get sometimes 0.1, 153, 153, 153 and so on. So how can you express this two or more than two digits? So you need to use the bar like this. Are you getting? That means these three are repeating. So 153, 153, 153, 153 like that. Okay. So you have to write this in your fair copy with this examples. Okay. So write this. Now we are going to see what is the criteria for knowing that this will be the terminating and that will be the non-terminating. So let's see that. So here is the criteria for the rational number to be terminating decimal. Now what is the criteria? You need to remember this formula, p upon 2 to the power n into 5 upon 2 to the power n into 5 to the power m, where this p is integer and this n and m are whole numbers. Now how this formula we have to apply? Say for example, if we have 11 upon 20 and we need to know that whether this rational number is a terminating or non-terminating. Now you know the meaning of that terminating and non-terminating. So what you have to do, you have to factorize this 20. So if you take the LCM of this 20, you will get this. So that is how 11 upon 2 into 2 into 5. So 11 upon 2 square into 5 to the power 1 can we understand in such a way. Now here n is equal to 2 and m is equal to 1, doesn't matter. As we got some 2 to the power some power and 5 to the power some power, it should be whole number starting from 0. It should not be negative. Okay, so 0 to infinity, anything it can be. So at least we must get 2 to the power something or 5 to the power something. Okay, then we can say that it is a terminating decimal. Okay, now for the non-terminating decimal, how we can convert the non-terminating decimal into the how can we convert the non-terminating decimal into the rational number? That we will see in the exercise. Okay, and rest how to compare who is greater, who is smaller between the two rational numbers. All this thing we will see in the exercise. Okay, so let's start with the exercise now. Okay, so let's start with the first question. They are based on rational number as decimal numbers. First, A1. Which of the following will change into terminating decimal? Justify. So first question is 13 upon 125. So will it change into terminating decimal? So for that we need to see that with the formula whether it is satisfying or not. So formula, as we know that for being a terminating decimal, p upon 2 to the power m into 5 to the power m should be satisfied. Okay, so 13 upon 125. On the side you can just find the LCM of 125. Starting with 25, it will give you 25, 5, 5, 1. Now see, here 125 is 5 into 5 into 5, this which is 5 cube. So can we say that, we know that 2 to the power 0 or anything to the power 0 is 1. Okay, so here to mold this thing into the formula, what we are doing, we are writing 2 to the power 0, and as I told you, this n and m are whole numbers, so they it is very acceptable here to write 2 to the power 0, which is 1, and 5 cube. So hence we can say this can be molded into the formula, and from here we say yes, it is terminating decimal. Did you understand this question? So in same way, if I take 2 upon 9, so 2 upon 9 is what? 3 square. Not even 2 and 5 is there in it. Okay, so we say that this is a non-terminating. And if you come to 23 upon 60, if you take LCM, so let's take LCM here, 2, 32. Then what is that? No, 15, 5, 3, 3, 1. So from here, what can you say? Is it a non-terminating or terminating? So on the formula, what can you say? Is it satisfying your condition or not? So see, 23 upon 2 to the power 2 into 5 to the power 1 into 3. Now because of this 3, we will say it is not properly fitting into our formula. That is why it is a non-terminating. Okay, it won't be the terminating one because this 3 is coming extra. Okay, then the next question is 7 upon 250. Okay, so tell me, will it be a terminating or non-terminating? So similarly, as you can see, the B question, you need to convert into non-terminating decimal. Which of the following will be converted and why? So again the same question they are trying to ask. In the third one also they are asking the same, that will it change in the recurring decimal or not? So again you have to check in this way only, okay, which is terminating and which is non-terminating. Question number D, if 3 by 14 is changed into decimal number, which type of decimal number will it be? So 3 upon 14. So this is what? 3 upon 2 into 7, okay, which is not fitting into our formula. So hence we say that this will give you a non-terminating number. Okay, so I hope you have understood. Now question number second, express each of the following as rational number. Now we have to see this question. Okay, what concept we have to apply in this question, this is very important for you to know. Okay, so let's see. Okay, so question number 2, we have to start how to convert non-terminating decimal into rational number. So the first question is 4.125 recurring. Okay, 4.1 give some gap, 25 recurring, so that when you read, so it should be understood to the other person that 25 is recurring. So 4.125 recurring using formula which is given on PA4, page number PA4. Please, in the blue box it is given there very clearly. Please write the formula over here. I have not written. So here is the question. Now please understand, because this might be confusing for you, so it is better to understand the concept, all the concept here itself. So this question we need to change it into the rational number. That means, see, this question is nothing but this. You know, if you divide it, no, you will get the non-terminating digit. So how we can convert? So first, whatever the number is given to you, remove all the recurring and decimals and write it here. So that is why this I have written as 4125 minus 41. Now what does this says? Before this recurring, how many digits are there? Now just forget this decimal. As 25 are recurring, so 4 and 1, that means 41 is the term which is not recurring. So you have to write here whole divided by 10 cube. Now this 10 to the power, how this 3, see they too will always be the 10 to the powers. Now this powers, how we have to see this powers, this 3 is after decimal place, how many digits are there? 3 digits. So that is how 10 to the power 3 I have written, minus 10 to the power 1. Now how this 1 came? After decimal, the numbers or the digits which are not recurring. So after decimal, 1 is only the digit which is not recurring. So that is why 10 to the power 1. So if you can see the formula, you just first you see the formula. Okay, there you will see such type of explanation is given. Okay, so from here subtract the things I have subtracted. This minus this is this. 10 cube is 1000 minus 10, and on simplifying we got the answer this. I hope you understood. Now let's come to the next one. Negative 2.03 recurring. So how to do this? Again, minus will be minus here. Then you have to put one bracket. Now remove the decimal and recurring, write 203 as it is, minus. Except the recurring digit, how many numbers, what is the number given here? 20. Remove this decimal. So 20 we have written. Whole divided by 10 square. Now how this 2 came? I hope you understood that we need to see how many digits are not recurring. Here 2 digits are not recurring. So 10 to the power 2. Now minus 10 to the power 1. How 1? After the decimal, how many digits are not recurring? So after the decimal, only 0 is not recurring. So 10 to the power 1. On solving, take this negative inside. So you will get the final answer. Now just give try to the next one. If you face any doubt, you are free to ask. Okay. So do these questions. Now the next questions are based on the comparison between two rational numbers. What do you mean by comparison? How do we compare? We only see who is greater and who is lesser. That is how we compare the things. So the same case goes here. We are given with this question. We need to compare, means we need to just write that which is lesser one and which is the greater one. Okay, so you can write in ascending or descending way, whatever you like. So what you have to do here, I guess you have done such type of questions in lower classes where you are given with the fractions and you need to arrange it into the maybe ascending order or descending order. Okay, and you know how the process, but let me again recall. So here this is 0 upon 1. So 1, 6, 3, 14, you take LCM of 1, 6, 3, 14. Whatever LCM comes, you try to make all the denominators same. If you can make all the denominators same, so it will become somewhat like fractions. So with the help of numerator, you can easily say that which is the lesser one and which is the greater one. And in the fourth question, the same thing you have to do. One question is of ascending order and another is of descending order. You know that, but what is the meaning of ascending and descending order? So the same criteria, you take all the denominators, take the LCM of that and make the denominators same. And with the help of numerators, you write in the proper way. So these two questions I am keeping it for you to do. I hope you all will do. Okay, let's see the next now. See, third question here. In the answers, they said largest and smallest. So that is also correct. But okay, in the question it is mentioned largest and smallest. No problem. Okay, the same criteria you follow. From there, you see which is the largest. You write that one largest and smallest, that one smallest. If you won't get, just let me know. Okay. Now let's come to the fifth question. Okay. So question number 5th now. What does this question says? Determine a rational number between the pair of numbers in each of the following. So we need to find a rational number between 1 upon 3 and 2 by 5. So they two are also the rational numbers, and we need to find one rational number between them. So like there are 2 or 3 ways for finding the solution of this question. So let's see the easiest one. Now, can we think that if I find the middle number between these two, that will also be the rational number, and that will lie in between of them, in between these two. Okay, so how do we find the middle number? It is nothing but the average. In the statistics chapter, we have seen the mean, the average. Okay, so that is what we are going to use to find the middle number. So you add both of them and you divide it by 2, you will get the middlemost number between these two. Okay, so how? Solution: 1 upon 3 plus 2 upon 5 whole divided by 2. So how? 5 ones are 5 plus 3 twos are 6 whole upon 3 fives are 15 whole divided by 2. 5 plus 6 is 11. So this 15 into 2, so 11 upon 30. So 11 upon 30 is that rational number which lies exactly between 1 upon 3 and 2 upon 5. So you need to use this concept. So 1 upon 3, 11 upon 30 and 2 upon 5. Between these two, you have found one rational number. Can you find, like if I ask you, you find 3 rational numbers between these two. So what? Now you will use the concept. Between these two, you have 11 upon 30. Now let us find between these two. So we can easily find 1 upon 3 plus 1 upon 30 whole divided by 2. Here 30 plus 33 upon 3 into this 90 whole divided by 2. It will give you 63 upon 180 or 21 upon 90. So in between of them, you got 21 upon 90. Similarly, can you find a rational number between these two, this one and this extreme value? So you will get one more answer. So that is how you can easily find the 3 rational number. You go on using this concept, finding the middle term. Okay, between first of all these two, you will get this. Now this one and this one also, because between this one and this one, this 21 upon 90, it will lie between 1 upon 3 and 2 upon 5 only. So that is why this is acceptable. So you can go on finding the middle terms and you will get the question. Now in this 5th, 6th and 7th question, in the 5th question, they only talked about the one rational number. Now if you see the 6th question, you can see that they are asking 2 rational numbers. So I told you, first you find in between these two and these two. So that is how you will get 2 rational number. In the 7th question, they are asking 3 rational number. The question is same. The process is also same, you have to apply. For 3 number, first of all these two, this one, then this two, then this two, you can find. So that is how 5th, 6th and 7th, please try to do. Okay. Now question number 8. Place the following on the number line. 1 upon 3, we have to place it on the number line. Okay, so let's see. Okay, now understand how to place the rational number on the number line. Okay, so you are given with 1 upon 3. I'm taking 2 specific cases, 1 upon 3 and 5 upon 3. Now what is how you have to understand the things. Now if you see 1 upon 3, we know 1 upon 3 if I divide, I'll get 0.33 and so on and recurring. So with this information, I can at least guess that on the number line where this number will lie. As my answer is 0 point whatever, so I can at least estimate that it will lie between 0 and 1. So always whatever rational number is given to you, you just try to divide it so that it will give you an information where your rational number will fall and between whom. Okay. So 0, that means it will lie between 0 and 1. Now how you have to manipulate this? 0, can we write 0 as 0 upon 3, because 0 upon 3 is what? 0 only. This 1, see I have the denominator 3, that is why I told 0 upon 3 is 0, and 1 can be seen or 1 can be understood as of 3 upon 3. Because 3 to 3 will be cancelled and we can get 1. So that is how we understand 0 upon 3 and 3 upon 3. Now between 0 upon 3 and 3 upon 3 there lies 1 upon 3, 2 upon 3, then 3 upon 3, like that. So between 0 and 1 you have to make these two lines, which this line will be 1 upon 3, this line will be 2 upon 3, and as we want this, so we have expressed 1 upon 3 on the number line. Only this much you have to do. Now if you come to this case, 5 upon 3, you are on dividing, you are getting somewhere like 1.6 and whatever, we don't have to go that much. So 1.6, at least we can estimate that this 1.6 will lie between 1 and 2. Okay, so here making the number line 0, 1 and 2. I'm making this broad because maybe we'll draw the line, so it will help us. Now this 1, can we write this 1 as 3 upon 3? Because denominator is 3, so 1 can be seen as 3 upon 3. 2, how can we write 2? Can we write this as 6 upon 3? So I'm writing that as 6 upon 3. Now between 3 by 3 and 6 by 3, there comes 4 by 3, 5 by 3. So whatever is required to us, 4 by 3 and 5 by 3 we got. Likewise you have to solve the other questions. So please solve it, and that is how we completed the exercise. Okay, I hope you all will do the homework. Thank you so much. Have a nice day. Keep studying, keep yourself safe, avoid going outside, and be happy. Thank you.